So I want to set myself a little challenge. I want to remake Stardew Valley, specifically the farming part, but using only LPC style assets. So what is an LPC style asset? Well, it is something like this. They are 32 by 32 pixels, and they were part of a pixel-like art competition back in 2012/2013. And it's kind of a standardized approach at creating artwork. So if someone wanted to contribute, if they followed a style guide, they should all work intangibly. And this guy, Blue Carrot 16, has some nice assets I want to use. And yes, this really nice farming one. So you see here all these different stages and all these different crops. Perfect what we need. Also got this lovely terrain set that use Wang tiles. You may have seen this where I did a whole video on this, on how to auto tile. I'll also just link in the corner that you can go and view yourself. And he also has a fruit trees one, and these are just very cool looking. That's not all he has, other assets, but I'm going to keep it simple. Let's just focus on those three ones for now, and if we want to add the ones later, we can do. And for my language choice, I've been learning a bit of Odin. You may have not heard Odin, but the best way I can put it is it's like C, but has like a lot of the modern cool features of Python, specifically with the packages. So you can just import stuff just like you can in Python. You don't need to do like all this building and running it is very quick. So what you get is performance that is similar to C while getting that ease of programming with something like Python. It still requires memory management, so it's not like Python, which will just automatically delete memory for you. No, you will have to do that yourself, and so there are risk of memory leaks, so we have to be careful of that. But besides that, we get you get the juicy performance. And it also has, if we look at packages and we just search Raylib, that Raylib is pre-installed, meaning that you just have to import it. It's like super easy, and it also comes with Rage UI already pre-installed. And this is kind of becoming a popular language of game developers. That's why I want to try it out and use it in this project. Like I said, I already have an auto tiler that I writ originally in Odin. Now I demonstrated it in Python, but I still have the code for this. And as you can see, that this is what it looks like in my video, and I can actually just launch it straight away like this, run.0, and there we go. Look, it's the same, in fact, the same seed, and I had it where you could just edit it. So I'm going to reuse that code and clean it up a little bit. All right, I've made some pretty good improvements, and let's just run it first to show you what I've got. And let's just run let's do the Odin run dot. Nice, okay. Here we go. Look at this. I've added foliage. I've also changed dirt to be a nice marble. And there are other things. I also did some testing on the placing. So look, oh no, now the player can place the farmland. And I also just wanted to test removing foliage. So here we go, yeah, like that. Pretty cool. And it also, these trees are ordered. So they're using the painted algorithm, I guess. But as you can see, I'm using ordered remove, which is an Odin feature, which seems to cause the next thing to flash, which odd. So it might do, I don't really know. There's an unordered move, which is faster, but then I don't know how that affects ordering. Like, is it gonna fuck everything up, which is basically what's gonna happen. So this is it. It's just a small world. Let's just go over some of the changes. So I added a new one, which is plants here. So this Blue Carrot again had another one called plants. So you can see there's loads of like cool stuff to render for foliage and stuff. So you have some nice flowers. We even have stuff water. These water reeds might be cool to add, like here. Those should be fun. Fallen logs as well. And there's also a trees pack, so we can get some much bigger trees if we want to, because the ones that we saw in the game was only 64 pixels high, which is the highest as the player. And so just loading those bad boys in. Generating the foliage is really easy. When we do the create a 4-bit mask, I'm just checking if the tile is a grass, and I also just check if it's an auto tile at 15, because 15 is like it's surrounded by grass, so that means we won't get one that will generate like on a corner of water. And on top of that, for now, I'm just then I check a value from 0 to 100. If it's greater than 75, then place it. But I wanted to take a better approach and have, I think, another layer of noise. So there's like sections of the map that are just like have no flowers or anything, or maybe a different variety and such. So it'll be like, oh, this area is more densely packed with this foliage on as compared to this one. I think that will be a really nice addition to have. The only other thing was the setting the origin, which is So when I click, it will actually like delete the things. But as you notice, you see how these are now on the edge or outside the zone, because these are centered at 0, 0. So when I click it, it works on that corner. But if I set these to 0, 0, they'll be out of line. So they are like this now. But I think this is fine. As you can see, when I place and take tiles, it's basically the exact same spot as placing tiles. So what we can just do is just ignore edge cases essentially. Oh, I think I crashed it because we went out of bounds. Oh, yeah, we did. So that's another thing to fix. I just want to have an appreciation for Odin's maps and makes. A map is kind of like a Python dictionary in that you can obviously have like here a struct and and keys assigned to it. But as compared to a traditional like array, with element 0, you'd be like, oh, I want to search for 0 and then in this array and then find it. With these maps, you can just simply specify where it is and with the key. So this could actually be a string, and I could tell it, pass it in like, I want this key value. And so if we go to our tile locations, we're using maps here as well. So earth tiles, for like farm or grass. And when it comes to our loop to render it, down here, we just loop through the layers, get a key, and we can just pass it through the array here. I did also make some optimizations. Like I said, one was when you click, it was regenerating the whole tile layer array, which is really inefficient, especially for much larger maps. Some people with slower processors would cause lag spikes. In this case, all I do is check in the neighboring 9 tiles, and this is what I have. Essentially a repeat code. Probably could do a bit more like cleaning up because it's essentially a copy of this, but for now it works and causes no memory leaks that I'm aware of, because we are deleting the array assigned. And this is where having multi-dimensional arrays in Odin does get pretty complicated with assigning values and deleting values. You can see how quite chunky this is getting. If I just stretch this out, the way it works is that because this tile layers is an array struct, so it needs to be. So I create a new array which is making of a dynamic of the layer struct, and I didn't append the elements to it, which is from if there wasn't an existing value to it, and then I create a new slice from that, which is of the length of that array. Then I copy that and then I assign it to that value. Then I delete that new array. Otherwise, you make a new layers that are just stuck in the memory. So it gets stuff like that can get pretty crazy when you're dealing with array without a garbage collector like Python. But if you want that efficiency, that's what you need. Another interesting thing I discovered is that maps are, even though I find the maps like this in the code, so you might think that this would be made in order when the code runs. No, it doesn't. They're actually completely unordered. So I've set up a fixed array of the items I have. So when I go through and loop through them in the key, this one here, this break 4-bit mask, I loop through it from the tile order, because the issue I was having is that I want them to be ordered in this order. So the water is, when Raylib renders, right, the last thing is always rendered on top. So if farm was rendered and then water was then rendered on the same position, water would be on top of it. That's how it sort of orders its rendering. But if I were to call earth tiles, there's a chance that they're not ordered when they're made. So that means you have to actually have a separate array to it, which is, like I said, is the sort of purpose of maps aren't meant to be ordered, they're meant to be unordered. So you do need 2 arrays when dealing with it. But the benefit is that you can just call directly to that map array. So you have that convenience of them. The same with this one as well. I just did it through this order, even though I possibly don't, because there's no essential reason. It's just appending them to array and they're randomized. But I have that just in case anyway. This does obviously take up more memory because you have 2 arrays, but these are they're tiny really. 4 so far, they're a length of 4, not much, and I don't think we'll add any more tiles for now. But memory is very, very cheap these days. And we're only using up at best kilobits of data of the RAM, so we don't need to worry all that much. I've generated this nice, wonderfully procedurally generated world, and I've added nice little trees to it. We need to chunk it. We need to do some optimization. And so, if you ever played Minecraft, Minecraft handles its world in chunks, which I think are 16 by 16. And that means that you're just not rendering the whole world, you're only rendering the chunks within a certain distance. And that's essentially what I've done here. So I have a globe variable called the chunk size of 20. And if we scroll down, so here's our original one where we just loop through every tile that's within the world and then display it. Not very efficient if it's a very big world. So this one, we just need to get the player's position and then find out what chunk it is. And so we get the chunk size, and we're checking it across the map size as well. That's the maximum chunk. And so scale here is just 32, which is how big a tile is, just getting the correct scale of it. And we get the position relative to where the player is and the chunk X or what, and then we find out what chunk they are within. We know when they cross over to a different chunk. And all we are is checking if, so for the chunk X and chunk Y, it's just like the X position within that chunk and then the Y one. And we're just checking, hey, is it above 0 for the current position? Because we want to render the chunks above corners and next to it. And so if the player's already in the corner, the cornermost map, we don't want to render the one above it or the one to the left or the one in the top left corner, because that will be an error that will cause out of bounds issues. So we don't want that. So we're just doing all that, and then we just run them all. And then for the foliage, I kept it out because we can get rendering issues. So like overlaps. So one chunk would have been rendered first, and then that will result in like top trees being cut off, which is not what we want. In this case, we just get like the furthermost corner and the furthermost bottom right, and the positions just make that one big chunk in this case. And so if we just look at the chunk to show the original, we're getting just the start position, the X and Y, and the end position of the X and Y. In this case, my code's a bit sloppy. So this was code I wrote actually a long time ago, and I actually got from Go. I wrote this in Go, so I've kind of copied it over. So you can see here that we're actually adding +1 to chunk X, and we could probably actually just pass it through, but that's a whole different thing. And then what you do is you go through, and so you start from the side, and you just go where the index, and because our array that we have already has the position within its key, we just put it right in, and then it'll render it. So we've reduced the optimization of this, improved it, because loops are of ON complexity. So the more elements you have, the greater the time it takes to process in linearly. But just to give you a visual idea, ON is here. You see that it gradually goes up as there's more elements. So N is the number of elements, and it's a fair case. But it also means that if we can reduce the elements, we can significantly get better performance. Now for our foliage, it's a bit different, because I said that we have two arrays. One is the arrays of the item, the interactable map, which has their key where they should be on the world. It's unordered, it doesn't really matter. And then we have our ordered array, which is all the elements, it's just an array of integers in order. So 0 is the one in closest to the X and Y of 0, 0. And that means that we can't just directly insert, we have to find it's where it starts and where we just loop through. We could just loop through all the foliage again, but again, that's just very complex, and then just put an if statement. But what I've done is I've used Odin's binary search, which is a very optimized searching algorithm. It's very, very efficient at finding something. And in this case, we actually only run it when we need it. So if the chunk has changed, then we run the binary search. So we even have some extra optimization. So I have a global array, so it's global position and this global current index. And the way this binary search is that the thing is, we won't get guaranteed. We probably won't find the element that happens to be at the position, but it gives you the second best result. It says, hey, couldn't find it, but here's the closest we got. So it'll give you the index it got closest to, and it does actually give a second element which tells you, yes, true, we found the element, or true, no, or false, we didn't. So in this case, we actually don't care if we find it. We just want the closest element, it is on the index, and then we take that, and then for that, so we just start, that's the first position we start looping through, and we just do it as normally as it was before. We loop through it, but then if we find the position that is greater than the current size, so the end size is the NY and NX of our chunk, so the last position it can be. And if we just check, hey, is it greater than that? Then we break it, we end the for loop. That means we only need to loop through the items that we want to render. And this saves some performance. It's nothing huge, but we can put a few percentages off. But to give you an idea, a world with about, if we render it the traditional way, this world of 100 for me, get about 2% CPU usage, which obviously might not thinking up, but when we render it with just around the player, we can drop it down to like 0.75% usage, or even lower. It depends if the players are moving. So that's that's a you think of a difference, that's a very big difference. Will benefit more people lower end hardware. So I can demonstrate the chunking stew by setting the chunk size to 5. So there are only 5 tiles per chunk, so we should be able to see it. We run it. There we go. So we can see that it's only rendering that small section, and if I move as the player to find it, you notice that it keeps going and keeps going, and eventually chops it all out. Just super nice, and this is great at saving. You save a lot of bumps with this method and it's really good if you want to generate very large maps. So, and as you can see, we're at the edge here, and it will not bother rendering any of the edges because you don't really need to. And so when I back it back up to a bigger size that covers most of the screen, and we run it, there you go. It's like you can't even tell that the stuff hiding is because it's being generated as the player moves. We've got a chunking system, and check this out. We've now got collision going as well. So if I walk up to these walls, you can see that it kind of works. You see it's a bit chunky from the left side, but also here foliage is all collided well. Nice. From the right, ooh, it's a bit weird. In some instances, like here, like going down, it's perfectly fine on the geometry, and that's because we're using the grid base thing. I think I'm just going to leave it like that, and let me just check it out. Remove this bush. So if I remove that as well, it appears. So that you can go in here, you can get full control. I'm kind of just thinking, yeah, does it really matter if the player can slightly go over the edge for now? I mean, it looks a bit janky here. You can see, like, oh look, they can go really far in. But you can tell that it's a grid. You can tell that this section here is the water because of the way it's like reorganizing. It's obviously not pixel perfect, and plus the player height is. What I discovered is with the frame animation, if I go back to this, let me just also check OBS. If you go to the male walk cycle, they're not actually directly next to each other. So the actual width of a frame is currently 64 by 64, and that results in the offset in the player animation having to be 64 64, which causes some issues. So we did a check collision. We're checking it once just for the world map. And so I apply like a little 16 pixel offset, which I found successful for the world tile for the male. And all it really is, and because we have again this map, we actually don't need to loop through the array. We can actually just directly import it. We know where the player's XY. We just get the map position divided by 32 because we're looking at it in terms of tile space. So we have that, nice. And then we just check, hey, is this water? If not, return false. And then else if, we also just check, because of the way it rounds up, point decimal values because it's a float we're passing through. If the player could essentially walk off at the edge of the map because it was not reading, like it was rounding up or whatnot, or rounding down, and it didn't really see it. So we have to double check. I'm rounding up by just converting it back to an int and just check if it's 0, and then that means they can't walk out. And then for the foliage, which is we're doing the same check, we just return it. For now, if okay, that means the element exists. That means we can't walk through it. But in the future, we will need. In the future, we will need in foliage gen here. We should add a new one called like the ball, which is. We want the player to like walk through bushes, but not trees, for example. So that's it for now. Also, I made it so the player spawns at random locations. So that means they don't just spawn in water, otherwise they will get stuck there. But it's not perfect because, again, with the offset, like, oh, foliage is not exactly on the grid. It's not 0, 0. It's sort of like, oh, only the bottom section we want is on that point, and it kind of results in sort of dodgy stuff. So it can find the wall fine, yep. I also go for the keys and just check if it's like, oh, if it contains any water tiles. So it might be a grass tile, but underneath it might have an edge of water, for example, and the player will actually get stuck on that. And so with that, we also just check if it's, we also check if foliage there, then the player shouldn't spawn. And it's just an infinite loop, and it keeps doing it until it finds a good place. It's not perfect. In fact, if I perhaps keep running this, so let me close this down and relaunch it. Okay, so here you go. My character is spawned on this tree tile here, and if I press the arrow keys, I can't move. And if I remove it, there you go, I can move. So there's some issues there with getting the player to generate. I've also sorted it so you see, look, the player appears behind the tree, and if I walk in front of it, you see the rendered in front, and it's just a really simple paint scrub that we already had for our foliage here. We check the chunk. We're just getting the player's size, so the position they are, and just check where they are on the grid of the map. And then you firstly check if it matches the element. That means they're on the same tile as that foliage, and check if the Y which is our depth in this case, is created on the Y position of the foliage. If it is, then render the foliage first, then render the player. So that means the player will appear on top. If not, then this should actually be below. Why is this else? Let me fix that. It should be like that. So render the player first, then the foliage. That means the player will appear behind. And if that never occurs, that means the player is not on a foliage tile. It means that we just check if it's within the range and then render the player. So what we do is we check player side. We're basically doing a sort of searching algorithm, checking if it's greater than the element, but also checking if it's less than the next position. So we're still rendering it in order. That means we also only render the player once. I also restructured a lot of the code. I put the player and everything just in one package now. The LPC value, basically the whole game is occurring in this package. This what it's called. But I can have all the names of the file. So player.odin is still its own file, and I can select all its variables in there. It's just made it like so much easier than rather having player its own package, because that means I have to pull to it and fetch that stuff, and it's just harder to interact with. You need to sort of properly plan and think about how you're going to really structure that for that to be really effective. This approach is convenient, but can be complicated. So if you think about a game gets really big, you've got a ton of global variables just all over the place that people could change and whatnot. It's not terrible, but in this case it's just super convenient. The collision detection is also super primitive, because we're just checking if they're in the tile or not. If not, then they don't move there. So we just when a player presses the arrow key, check that new position is in that tile that they can't move in, and if not, then they don't move there. It's like it's issues like I said, if I rendered it, there was a lot of issues with the offset so far. You can see I'm like sort of in the water, because you're checking by the pixel underneath it, and you can see like here it's where it's really bad, but it's okay for now, and it's also pretty efficient in terms of like there's not many calculations really going. We're just doing an if statement, and because we already know the player's position, we could just directly check an array. If it's that then don't. So it's actually great. We're not doing any looping. We're efficient with that. So I do like that approach. It's also the same with our sorting here. Like this, so it's very specific for my needs. If I go back to the map gen and we scroll down to where the player is rendered, past it here, if we wanted to add other entities like enemies, then this approach is not the best. Really, we'd want it so the player is and other stuff is in their own array and it gets sorted. But with this approach, I don't need to resort the array so far. When we add it, so objects are inserted, so when they start planting crops, we will then need to resort the array. But that's perfectly fine, because we're just doing it on click, not every frame, which can happen when you're doing with enemies all moving around. That means that you're having to sort every frame because their position changes. So here's our world. It's coming along pretty well so far. We need a few changes really. So we have most of the generated world done. You can see I've also got it so now it generates a nice little sea outside the world map, which is awesome. But we need to now do a lot of the actual farming. We can actually obviously place tiles, as we see here. We can also destroy trees like that. Awesome. And the next thing we need to do is be able to let the player plant crops, sleep, and then let the crops grow as well. And need to choose a selection of crops. Player also needs some clothes as well, because they're just naked. We'll need like some saving mechanic, and we also I guess need to figure out a way like where they sleep. Like, do they have a house that they start in? Other additional things I want to add is, for example, all these trees and bushes. I want to add more variety. Like we said in the actual, we close this down and look at the VS Code and the image. So the plants, look at all this choice we have. We have these reeds to the water I want to add. That would be really cool. Flowers are nice, so I think we could add perhaps a multi-layered noise to add add biomes and stuff, like something really simple. Trees, more trees. Well, we also have much larger trees. That'll take a significant more time, because we need to code in the fact that these are like bigger width. So when the player applies them, it needs to actually know that this is more than just one tile lies. It's like the size of 2 tiles. We'll have to make changes there. And on if we go back to the website, back to our blue carrot 16 with their artwork, they have one for like tools, you can see here. But I think the website is actually really slow. But we have one for like that, a hoe, it's like a pickaxe one. You've got a fishing rod one here, pickaxe you see. He also has other ones, but I think we can, Yeah, he's got loads of stuff. He's actually still active. This was actually uploaded in 2024, which is pretty cool. So this person still does upload new assets every so often, which is pretty nice. So I really started making this just over a week ago. We made some really good progress within that week for what we have. We got the tile place, and then we got all the noise. We got the movement, the collision, all that. We still got some obviously stuff to do. So do stay tuned because we've got some more, but we'll have part 2. Hopefully, have all the farming done by then, and we'll have a getting close to a pre-finished game. So I'll see you until then.